Hi everyone, and welcome to this session grade 12s, where we're going to look at answering some of the questions that you would have had to practice on your own, and we're really going to look at the ones that you maybe would have had a slight problem with, or things that often learners get confused with. We'll try and discuss and solve all of those kind of issues in today's session. So we're going to look at circle of center, because of course that is the big thing that you learn about in grade 12. But certainly you need to remember all of the grade 10, 11 analytical geometry that you've already learned, gradients. We know we spoke about parallel lines and perpendicular lines, and we also spoke about equations of straight lines, all of those things up until grade 11. You still need to remember all of that as you try and look at your grade 12 circle of center questions. Okay, so let's have a look at the first question. You are given the circle with the equation x squared plus y squared plus 6y minus 4x minus 12 is equal to 0. So we can see that this is not in a form where we can read off the coordinates of the center, or where we could read off the length of the radius. So when the question says determine the coordinates of the center of the circle as well as the length of the radius, straight away we know that there's going to be some work required to do this question, okay? What kind of work are we talking about? Well, to rewrite this equation into the form x minus a squared plus y minus b squared is equal to r squared, we have to use completing the square, and we have to then rewrite the equation they gave us into a familiar form, which we can then use to read off the coordinates of the center and then the length of the radius. So the first thing you need to do is you need to group together your terms with x and your terms with y, and take the constant over to the right-hand side. And then at the same time, we also need to make sure that the coefficient of the x squared and y squared term is 1, which in this case it is. If it isn't 1, you will then need to divide through by whatever factor is in front of that x squared and y squared. Okay, so I'm going to rewrite this on the next screen. So we've got x squared, I'm going to put it together with minus 4x plus y squared, and that goes with the 6y plus 6y is equal to, we're going to take the negative 12 over to the right-hand side, so that will become positive 12. Okay. Once we've done that, we now have to complete the square with the two x terms and with the two y terms. So basically, we're going to create a perfect square which we can factorize. So to do that, we bring down the x squared and the minus 4x. We then find a half of the b term, so a half of negative 4, is negative 2. And we add that squared. Now remember, this is an equation and we've got to keep it balanced. So if I do that, if I introduce this plus minus 2 squared, I will then have to do the same thing on the right-hand side, because in an equation, whatever you do to the right-hand side, you do to the left-hand side, and whatever you do to the left-hand side, you do to the right-hand side. All right, so that's plus minus 2 squared. And then we find y squared plus 6y, we find a half of that b term and add it squared. A half of 6 is 3. And we add 3 squared to both sides. Okay. Now on the left-hand side, we can factorize x squared minus 4x plus minus 2 squared is just going to give me 4. So I'm going to get x minus, we take the sign of the middle term, minus 2 squared plus the square root of y squared, which is y, plus, so we take the sign of the middle term, 3 squared is equal to 12 plus 4 plus 9. So therefore I can see the coordinates at the center are going to be 2 and negative 3, and I can see the radius squared, 12 plus 4, 16 plus 9 is 25. So the coordinates of the center, we always change the sign as we take out of the bracket. So therefore, the coordinates of the center of the circle will be 2 and -3. So that's the coordinates of the center of the circle. And then the radius, remember this is your radius squared, is 25. So therefore, your radius is going to be the square root of 25, which is just 5. Okay, so that is a simple application of completing the square to find the coordinates of the center of the circle and the length of the radius of the circle. Some of the important things you need to remember here is that when you complete the square with the x squared and with the y squared both all on one side of the equation, the left-hand side, whatever you do to the left-hand side, you've got to do to the right-hand side. So you need to remember to add a half of each of the b terms, add that squared to both sides of the equation. All right, guys. Also, another important thing you need to remember is this is always, when we've got x minus a squared plus y minus b squared, it's always equal to r squared. So when you asked for the length of the radius, we'll say, therefore, length of the radius is equal to 5, not 25. That's an important thing that you need to remember. Okay. Now, another typical type of question that you can be asked about is to find the equation of a tangent to a circle. So I want to start looking at question 2, where we are given the diameter of a circle, and then we are asked to perform some work on the diameter and help us to then find the equation of the circle from the diameter. So let's have a look at question 2. It says the diameter AB of a circle has coordinates A and B. So what I like to do is I like to make a sketch of the given information. So we've got the coordinates of A as 1 and 4. And then we've got the coordinates of B as 7 and 0. Of course, it's a rough sketch. There's no axis. It's just to give us an idea of what's going on. Because they've told us that this is the diameter, AB, we know that that's twice the length of the radius. We also know that the midpoint of the diameter would be the center of the circle. So half the diameter will take us to the center of the circle because it's the length of the radius. Okay? So if I could find the midpoint of AB, which I can do using the midpoint formula, then I will have the coordinates of the center of the circle. So just by reading the information, and not really reading the question yet of what it is they want us to find, but just by reading the question and marking down some information, I already start thinking about how I can use the given information to help me later on. So when you look at part A, where they say, determine the equation of the circle, well, I know to find the equation of the circle, I need the center point, and I need the radius. Okay, so to find the point AB, the center of the circle, while I've got the coordinates of the diameter, so if I find the midpoint of AB, I will get the coordinates of the center of the circle. And I can then use either the length of the diameter and find a half of that to give me the length of the radius, or I can use the coordinates of the center of the circle to find the length of the radius using the distance formula. Okay, so you can see how we can already start answering the question just based on the fact that we've drawn a diagram. Okay, so let's start by finding the center of the circle. All right, so remember the coordinates of A were 1 and 4, and B was 7 and 0. Okay, so to find the midpoint of AB, the midpoint of AB, the coordinates would be x1 plus x2 divided by 2 and y1 plus y2 divided by 2. Okay, we can call this x1, y1, x2, y2. So x1 plus x2, 7 plus 1 is 8. y1 plus y2, 4 plus 0 is 4. So therefore, the coordinates of the midpoint would be 4 and 2. So what that means, because this straight line wasn't just any straight line, this was the diameter, that means that the coordinates of the center of the circle are 4 and 2. When x is 4, y is 2. So now what I said to you is you can either use that 4 and 2 to find the length from the center of the circle to either A or B using the distance formula that will give you the radius squared, or you can find the length of the diameter and then you find a half of that. So take the length of AB, divide by 2, and that will also give you your radius because remember, your diameter is just 2 times the radius. All right. What we're going to do is we are going to use the length of the diameter. And I'll tell you why I'm choosing to do that. Because if you've made any mistake with finding the coordinates of the center of the circle, if you now go back and use the coordinates they gave you, which was A and B, you are not going to carry that mistake if you did make a mistake in part A. You're not going to carry that mistake through into finding the length of the radius. But if you are 100% sure that 4, 2, yes, it's definitely right, then you can certainly go and find the length of the radius squared. If you've done it correctly, you should get the same answer as if you find the length of AB and divide by 2. All right, so the length of AB, so again, we're looking at 1 and 4. And 7 and 0. So the length would be, it's going to be x2 minus x1 squared plus y2 minus y1 squared. That should be a 1. And then 0 minus 4 squared. So 7 minus 1 would give me 6 squared. Plus 0 minus 4 is just 4. 4 squared is 16. So this will be 36 plus 16. And then we could add that together. Let's see what we get. 6 and 6 is 2, carry 1. 1 plus 1 is 2. 2 plus 3 is 5. So AB squared is equal to 52. So therefore, if we then find the length of AB by taking the square root, we'd get AB is equal to the square root of 52. And then your radius would be equal to the square root of 52 divided by 2. Okay, and we're going to do a little bit more work on this when we come back. Let's take a quick break. Think about how else you can simplify this. Have a look at finding the coordinates, using the coordinates of the center to find the length of the radius and see if you get to the same thing. We're back after this. Welcome back, everyone. So just before that break, we were looking at finding the coordinates of the center of the circle and then looking at finding the length of the radius of the circle because that is what the question asked us to do. So just to go over what the question said, it said that we were given diameter AB of the circle with coordinates of A, 1 and 4 and B was 7 and 0, and we had to find the equation of the circle. So where we left off, I said to you that the radius is equal to the square root of 52 over 2. Now you could be asked to show that this is equal to square root of 13. How would you do that? You will simply we're simply going to just simplify within the surge a little bit. The square root of 52 is the same as 13 times 4. And this is over 2, so this is the length of the radius. The square root of 4 is 2, so therefore I get 2 root 13 over 2. The 2's will cancel, and I'll just get the length of the radius is 13. So whether you use the diameter or you use the center of the circle and either A or B, you will still get that the length of the radius is, in fact, square root of 13. So the question here didn't ask us to find the length of the radius. I just went further to show you how we would find the length of the radius. The question here said determine the equation of the circle. So where we would leave it is, what do we have here? We've got the center is 4 and 2, and we've got the radius is 13. So therefore, our equation would be x minus 4 squared. In fact, let's erase all of this in here so that we can see what's going on. So our equation is going to be x minus 4 squared plus y minus 2 squared is equal to not 13, the square root of 13 was equal to the radius. So therefore r squared, square both sides, would be 13. So x minus 4 squared plus y minus 2 squared is equal to 13 would be the equation of this circle. All right. Okay, and let's have a look what else they say. They then say in part B, determine the equation of the tangent line through the point A. Now remember, a tangent line is just a straight line that's touching the circle at that one point A. So this is where we now have to use that axiom. The radius is perpendicular to the tangent at the point of contact. Why is that important? Radius perpendicular to tangent, because if I can find the gradient from the center to the point A, then the negative inverse, because the lines are perpendicular, not the negative inverse, the negative reciprocal, will give me the gradient of the tangent line at point A, and then I can use the coordinates of A to find the equation of the tangent line, which is really just a straight line. All right. So let's clear the screen here and work on this slide. So we remember that the center is given by 4, 2. Let's call the center O. And it's touching the circle at point A with coordinates 1 and 4. So to find the equation, let's draw it again. We've got this happening. We've got point A there, we've got the coordinates of the center of 4 and 2, and we've got the coordinates of A. So I need to work out the gradient of the radius in order to find the gradient of the tangent. So the gradient of the radius is going to be equal to, remember the order is very important here, you cannot swap x1 and y1 and x2 and y2 around. So a good idea is to actually label your coordinates as x1, y1, x2, y2. We then apply the formula for gradient, y2 minus y1 over x2 minus x1. We're starting with y2, and it doesn't matter which one is x1, y1, x2, y2. So in other words, you could have called point O x2, y2, and you could have called point A x1, y1. That is fine as long as your order is correct. So if you start in the second bracket with the y coordinates, then you need to start in the second bracket with the x coordinates. If you started with the first bracket as your y coordinates, then you need to start with the x coordinate from the first bracket. All right. So we're going to say y2 minus y1 over x2 minus x1. 4 minus 2 is 2. 1 minus 4 is negative 3. So that's the gradient of the radius. The gradient of the tangent, and remember you have to give reasons here, is going to be equal to the negative reciprocal. So reciprocal of 2 over 3 will be 3 over 2. The negative of that, because the sign here is already a negative times a negative would make this positive 3 over 2. If you're struggling to understand why I'm saying this is 3 over 2, you can actually do a little equation on the side. You can say gradient, let's just find some space here, gradient of tangent times gradient of radius is equal to negative 1. You can then substitute that value for your gradient of your radius and then divide by that minus 1 so that you can get the gradient of the tangent. So you can do that equation and get the value of the gradient of the tangent out in that way. All right. Otherwise, just swap the coordinates around and change the sign, which is a much quicker way. So the gradient of the tangent is 3 over 2. Now you've got to ask yourself, are you done? And hopefully your answer is no, because they asked us to find the equation. So the question says determine the equation of the tangent line, not just the gradient. So we need to carry on. All right, and let's move on to our next slide here. So we've got the gradient of the tangent was 3 over 2. And we're using the point of contact as A. So A was 1 and 4. So therefore, I use y minus y1 is equal to m times x minus x1 to find the equation of the straight line. you can use y is equal to mx plus c, and then first work out the value of c and resubstitute your values for m and c to write your equation in y form. That's perfectly acceptable. So y minus y1, so this is y1, that's x1. Y minus 4 is equal to the gradient of 3 over 2 times x minus 1. Times that into your bracket, so we get 3 over 2x minus 3 over 2. Add the 4 onto the right-hand side at the same time. So we're going to add 4 here. So we end up with y is equal to 3 over 2x minus 3 over 2. So it's 4 minus 1.5. This you can do on your calculator. If you want to quickly do a little sum on the side, you can. So we've got minus 3 over 2 plus 8 over 2. So I've just found an LCD between the two. 8 minus 3 is 5 over 2. So you get y is equal to 3 over 2x plus 2.5, or 5 over 2. All right. And that, guys, is the equation of this tangent line that just touches at the point A. Now, there are many opportunities to make mistakes, careless errors in this question. So the things that you've got to be careful for, let's stress them again. When we ask you to find the length of the radius, remember not to give the length of the radius squared. Similarly, if you need to write the radius squared into the equation x minus a squared plus y minus b squared is r squared, remember to square that radius. Do not just write the value of r. You will lose marks for things like that. Another place where you can lose marks, when you're working out the gradient of a straight line, y2 minus y1 over x2 minus x1, it is so important to start and end in the correct brackets. So that is why I say to you, label the coordinates x1, y1, x2, y2, so that you can use the right values when you are doing that substitution into the gradient formula. Also, another thing to be careful of is when you move across your equality sign, change your sign. So minus 4 becomes positive 4 and so on. Also, when the question asks you to write the equation of your straight line in y form, remember to write it as y is equal to the gradient times x plus the value of the y-intercept. You need to leave your answer in that form. And as I said to you before, get into that habit of writing the equation of the straight line as y is equal to mx plus c, so that when the question asks you to do it or to rewrite your answer in y form, you already know what the question is asking. All right, I quickly want to have a look at one more question and just give you a hint and a clue on what you should do to answer the question. We won't be able to finish the question off, but I just want to give you some clues and you will be able to finish this one off for yourself. Okay, so this one says, you're given the circle x minus 1 squared plus y minus 7 squared is equal to 10. And it asks you to determine the values of x if the point x4 lies on the circle. So the first thing I would do is when I'm given a question like this, I make a note of what the center of the circle is. So the center will have coordinates 1 and 7. And I straight away write down, so that I don't make the mistake, r squared is equal to 10. Therefore, r is equal to the square root of 10. So straight away, I've got those things sorted out. And so if I need them later on, they're right there. And in the hurry to get to the answer, I don't make careless mistakes. Okay. Now, if they ask you to determine the value of x, if that point lies on the circle, if a point lies on the circle, it means that if you put this value in for x, you'll get that value out for y. So all you need to do here is simply substitute your x value as x, so it's x minus 1, that's going to stay the same, and you're going to replace y with 4. So you'll end up with x minus 1 squared plus 4 minus 7 squared is equal to 10, and then all you have to do is solve for x. I want you guys to try that and see what you get. You will get that one of the values for x is 2. And if you look at the very next question, it says find the gradient of the tangent to the circle at the point 2, 4. Now, because we've already got the center out, we can make a quick sketch and say, okay, well, I know that we're looking for a tangent at the point 2, 4, so let's say that's the center of the circle, 1, 7, and we just want the gradient, guys. See, they didn't want the equation, they just want the gradient, so we must answer the question. just the gradient. We mustn't find the equation. We will not get extra marks for doing extra work that was not necessary. So therefore, if I want the gradient of the tangent, I simply find the gradient of the radius, and then the negative reciprocal will give me the gradient of the tangent, because we'll use the fact of that theorem, radius perpendicular to tangent, to work out the gradient of the tangent. That is all that we have time for, but we've covered some of the key concepts that you need to remember as you practice your questions and you do your homework. We'll be back next time with more maths. Until then, keep practicing. See you later.